at Distributech 2023, one of the sponsors of these interviews, and these are interviews with thought leaders from around North America and the globe. Our sponsors are H2 Scan. H2 Scan is the leading sensor manufacturer for hydrogen sensing in a lot of different applications, in transformers, in battery room safety, in processes and safety, in industrial, and in the future hydrogen economy. So I want to thank our sponsors, and I want to thank all of our guests, and I hope you enjoy this interview. My next guest is Dave Meyers. He is the CEO of H2 Scan. H2 Scan is one of the sponsors of all of these interviews. So Dave, thank you for joining us, and thank you for sponsoring.
You're very welcome.
Notice the name up there, okay? I told him you'd get his name up there and it would be in print. Dave, we're going to take two approaches. The first approach is H2 Scan, as it says, is the advanced hydrogen sensing. So obviously you think of the hydrogen economy both now and in the future. Talk a little bit about what that means when we say hydrogen in the power industry.
Well, I think there's a trend to decarbonize, and so how do you get there? And hydrogen is one of those technologies that can be used for distribution of energy and storage of energy. So in that value chain, there's various pieces of equipment to produce hydrogen. So electrolyzers produce hydrogen. Existing gas pipelines and new infrastructure to transport it, obviously standard storage techniques to store it. And then from a storage of renewable energy, then that energy can be converted back into electricity as needed.
We talked to the head of innovation and smart grid technology for National Grid.
Yeah.
We talked to somebody from Dominion Energy, and both of them, if they did it once, they did it 3 times, green and clean. Green energy, clean energy. So green energy can be produced by green hydrogen, right? Talk about that, the difference between...
Well, I think hydrogen plays the most important role in really storage of renewable energy, right? Because solar power during the day, at night you don't have the energy. I think that's where hydrogen plays the biggest role, is because I think a large percentage of energy from renewables is lost. So how do you capture that? Without building more renewable energy, you can actually capture what you have and store it overnight, to use generate hydrogen during the day, store it overnight, convert it back into electricity at night, and maintain the power grid.
You see more and more of the idea that using wind and solar to bypass the carbon footprint and make through the electrolyzers, make the hydrogen, store it, and then use it for power. You see more and more of that, and part of the Investment Reduction Act, or Inflation Reduction Act, which was the dumbest name ever for a government policy, right? And the most important thing it did is every year they had to go through, especially solar and wind, had to go through another government program of politicians approving the next year. So planning was really terrible. Now they have a 10-year window for wind and solar, and they can really be serious about wind and solar as a power source. Hydrogen is going to play a huge part in that as they start figuring out how to store it. What are the problems when you make or store or use hydrogen that you think H2 Scan can solve? Because there's got to be a problem with, you wouldn't have a sensor company if you didn't have hydrogen safety or reliability issue.
Well, I think first and foremost, safety is paramount. Otherwise, if you don't have a safe operation, I'll call it the acceptance, consumer acceptance and so forth is going to be difficult, right? So they have to solve that problem. But from an operational standpoint, as a plant manager or somebody who's operating these systems, of course, safety is also even more paramount to you, because you're actually working with larger quantities and so forth like this. So, there's a couple of things. One is in the production of hydrogen, the electrolysis process of converting water into hydrogen and oxygen can have faults which result in hydrogen getting into the oxygen side, and so therefore having a sensor that can detect these faults is critical for the safe operation, okay? So that's on the production side. And then on the distribution side of that, they want to do blending with natural gas. Right. Because if you think about it, storing renewable energy and then converting it back into electricity solves the electricity problem, but there is still natural gas that's being distributed that has a carbon footprint. So how do you reduce that? You can reduce that by blending hydrogen in with the natural gas. So how do you blend? Well, what you do is you mix the two gases and control the concentration. So it's critical for the control of that concentration for the end user of that gas, specifically if a burner or a stovetop or a water heater or a heating system, those burners work under certain ranges. So therefore having a sensor that can control the concentration of hydrogen will allow these things to be implemented to transition from a percentage of hydrogen in natural gas to full hydrogen in the system in the future.
So hydrogen has been used in industry a lot. It's either used for production of something, chemicals, even medical, or it's a byproduct of something, like when they produce refined diesel. There's a byproduct of it, hydrogen. That whole industry and the need for and use of hydrogen, or to avoid hydrogen escaping, has been something that H2Scan has been involved in for a long time. Talk about that for a little bit, and because it's pretty much it is advanced hydrogen sensing, right?
Yeah.
Talk about some of the applications.
So, the company started about 20 years ago, and our first initial markets were the petrochemical processing business or refining business. And those are extremely demanding applications because it's not only just hydrogen, it's other gases. And if anybody knows anything about gas sensing, when you mix gases together, sometimes the sensors can be sensitive to that. What's unique about us is we're not sensitive to those other gases, and we measure hydrogen specifically. So that was the real value proposition for us getting into that market. How do I sense the hydrogen in these processes to ensure they're optimal, that the process is optimized to get the most out of it? And then so by only measuring hydrogen, we can ensure that we have an accurate reading to best control those processes.
So you have a lot of applications for hydrogen. Transformer monitoring. Hydrogen is a gas produced in that's my world, transformers. They are the heart of the system.
Our world as well.
Okay, transformer technology,
Right.
H2Scan. And I know that people at H2Scan make a case for, why not put hydrogen monitors on 100 transformers as opposed to putting very expensive 5-gas, 9-gas monitors on 10, that kind of equation. Talk a little bit about that and how we educate, particularly the utility industry, because they don't think that way. They tend to spec a very expensive thing and then it's built because the manufacturer just builds what is spec'd, right? But the idea that we need to educate the people that are specifying monitors, that they have another choice. They have a broad array. Why hydrogen versus, it's not that the 9 gases are a bad deal. There are places where they need them. A GSU, you need a 9-gas monitor. But why is it better to put hydrogen monitors on more transformers than select a few and say, these are our best transformers we're going to put on? Given too the fact that we have a demand curve for transformers, we had a transformer manufacturer on, said they have a backlog that is now up to 3 years. So get it out the door, put simpler monitors on it, and make your life easier. What is keeping them from doing that?
I think it's education. Well, there's two things. I think it's not being aware of the technology because it's relatively new to have something that's so low cost and can be deployed broadly. That's number one. But number two, I think it's also the incentives that these utilities get, right? They're incentivized by capital investments. And so I think, there is a trend to be performance-based rate systems. Some states are now moving that way. So if you're driving for optimal efficiency, and that is the primary motivation, then I think it makes a great case to do broader asset monitoring, especially today when you said the lead time is 3 years, the price is about doubled. I mean, these things have to be planned well ahead, and if you can't get access to the replacements for your transformers, you need to have something that extends the existing life of transformers. And so how do you do that? you can monitor voltage and current and load and all that, and that's fine. But if a transformer's had a fault condition or something like that, it can produce hydrogen. That means you're actually putting the asset at risk. So by measuring with a hydrogen, you can extend the life of your transformer because you know at what rating or amount of power it's delivering where it starts to cause a problem. So to me, I think all children should be treated equally. I think all transformers should be treated equally. They should have a monitoring system.
What a great dad. Given all of that, one of the things that we forget is for every new transformer that's produced, there's 100 of them out in the market, if not 1,000, right? Especially in industrial America. While I was the president of EPRA, we did a lot within the petrochem industry, and we had one refinery where we were trying to get them to decide how to determine what is a critical transformer.
Right.
Then look at the condition of that transformer and start making life cycle decisions not based on age, because best transformer ever made was made by Westinghouse in 1976,
yes.
Ever.
Just like your refrigerator in your garage.
Yeah, exactly. It won't die.
Yeah.
But they're not. You can't decide to replace them. You replace them by condition. Condition-based monitoring is what hydrogen monitors give us. How are we going to address people in that installed base? With one refinery said they had 4,500 transformers. We asked them to define criticality. You know how many were critical? 4,500. Yeah. So he said, well, if that's true, then none of them are critical. But we came back and we started to figure, and the whole point was, let's put monitors on the transformers that are most critical, or that you've already seen fluctuations because of load, as you said, right? And they began to move in that direction. That was an industrial, not a utility, that was an industrial. But utilities have more transformers installed. How do we convince people that it is not a bad idea, since you can't get them, right? The demand curve is crazy. You better make sure that the ones that you keep are the ones that are safe, reliable, and the greatest. How do we convince them? So I'm that utility, and you have to convince me to put on my install base transformer monitoring.
Right.
H2 scan.
I think it boils down to everybody has a boss, right? So
I've got one.
Yeah. So I think the thing is that we've run analysis around the rate of return of a deployment of capital for transformer monitoring. And because our sensor is so low cost and it's so long lasting, you're not servicing, you're not maintaining it, you can get a value proposition by monitoring more transformers and have a net value of that investment return on protecting your assets. So it's from a reporting chain. You have the person that's responsible for the asset, you have the person that's responsible for paying for the asset, someone responsible for the reliability of the asset, and all those people who can see value all along the food chain, both from a maintenance of it, from the reliability, from the cost advantage over time.
So we've got to convince, and hopefully you've just done some of that, convince people to put them on the existing ones and spec them on the new ones, especially distribution transformers. They're becoming more and more critical all the time.
All children are equal.
That's going to be my new motto, all children are equal. This has been an APC Technologies production, and we thank you for joining us. Our sponsors have been H2 Scan and Distributech. And of course, the communities of APC Technologies, which is Transform Technology, Power Systems Technology, Green Energy Technology, and Women in Power Systems. So thank you.